Hey guys, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So people, quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Quickly let me know in the chats with some fire emojis if all of you can hear me, if I'm perfectly audible, visible to every single guy. Everyone, people, everyone in the chats. Everyone in the chats. Everyone in the chats, quick. Welcome back guys, welcome back. Welcome back again to your Unacademy NEET English channel. Welcome back. So my dear students, as you all must be knowing, few days back I had given you the chapter-wise important topics of your physics, chemistry, as well as biology. I hope you know that, right? There were some 50 to 60 topics which I had given you from the subject chemistry, which are every year asked. Okay. Similarly, there were some 50 to 60 topics from the subject physics, which are asked almost every year. And similarly, there are almost like 80 to 90 topics in your biology, which are asked every year in your NEET examination. Perfect. So that's the reason why we have come up with these sessions, right? Because we are going to complete these short topics in very lesser time. I hope you know that. Every concept that will be discussed here, every concept means one question. Every single concept means one question in your NEET 2025. So do not miss out a single concept which we shall be discussing in this particular series. This is going to be the short and the effective way to score well when it comes to your NEET 2025 examination. Perfect, guys? Perfect. Are you all ready? I want you guys to let me know in the chats with some fire emojis, right? I want you to be very super excited about this particular session. I want you guys to be very super excited about this particular session, people. Everyone in the chats. Everyone in the chats. Everyone in the chats. All right, amazing. I can see there are more than 500 people watching and the likes are just 398. What is it? Yeah. I'm asking you to pay money for it? All right, that's great. That's great, guys. That's great. Perfect. One more thing I'm going to let you know before starting this particular session. The session is not going to be like too big. The session is going to be just for 2.5 hours, because in one session I'm not going to complete all the 50 topics of chemistry. No, I'll take 3 to 4 sessions in it for it. Okay, in 3 to 4 sessions I'll be completing all the 50 concepts of your chemistry. Perfect. Similarly, Yavar sir is going to take some 3 to 4 sessions in your physics to complete all those 50 to 60 topics of physics, and Ambika ma'am, she'll be also taking some 3 to 4 sessions to complete the same. Perfect. So you just have to be with us for 2.5 hours every single day. That's more than sufficient. Rest you can continue with your preparation, right? You can consider these as the bonus sessions. Let me tell you that frankly, right? Because all the 50 concepts means from every concept question is asked every year in your NEET examination. And please make separate notes for this particular series. Okay, make separate notes for this particular series. Do not write it in the normal notebook which you have. Okay, make a separate notebook for this particular series. And these are almost going to be some 50 plus 50 plus 100, almost some 200 topics we'll be discussing with all of you. Okay? Yes, everything will be done from the scratch only. Don't worry. Every single thing I'll be discussing from the scratch. And in the today's session, I'll be in total discussing some 10 concepts with you. In the today's session, I'll be discussing some 10 concepts with you, and 10 concepts means 10 questions. 10 questions means 40 marks guaranteed from the today's session. 40 marks guaranteed from the today's session. And please do share this video with everyone. Whosoever is preparing for the NEET 2025 examination, this particular session is going to be super beneficial for all of them. Okay, super beneficial for all of them. Perfect. Well, the concepts in the today's session, they are mixed. They are not only from physical, not only from inorganic, not only from organic, they are mixed basically. Okay, don't worry. They are mixed. Perfect. So should we start? I would want some fire emojis again in the chats. I want the chats to run continuously. And before starting the session, as I keep on asking you every time, which part of the country you guys are watching this session from? I just want to know that. Write the name of the state, okay, in the chats quickly. I just want to know which part of the country you guys are watching me from right now. Because I'm live from Srinagar, Jammu and Kashmir, right? Let's see from Srinagar how many states we are covering right now. All right. Tamil Nadu, Andhra, Karnataka, Tamil Nadu, Goa, okay, Jammu and Kashmir, Kerala, Telangana, Punjab, Mumbai. What is left? Bengal, Assam, Nagaland. Someone is from Mars. West Bengal, okay, Telangana, Haryana, Karnataka. Okay. Amazing. Pune, okay. Chhattisgarh, Chennai. Perfect, guys. Amazing. So I think people across the country have joined us for the today's session. That's amazing. That's great. Hyderabad, Manipur. Okay. Amazing, guys. Wonderful. All right. Perfect. And one more thing. Before starting this particular session, one more thing. The handwritten PDF of this particular session, I'll be sharing on my Telegram. I hope you guys are part of the Telegram already. If you are not the part of my Telegram channel, be the part of the Telegram channel as soon as possible. The name of the Telegram channel is Wassim Bhat Chemistry Official. Wassim Bhat Chemistry Official is the name of my Telegram channel, in which I'll be sharing the handwritten PDF of the today's session. Okay? Perfect. Amazing, guys. And one more thing, the ones who have not subscribed to this particular channel, I would want you guys to subscribe to this particular channel right now so that you remain updated about all the sessions which we are going to take on this channel from now onwards. Okay, because all the sessions are going to be very important. Okay, from every session, you are definitely going to fetch the marks, right? And some more series are coming on this particular channel, like the revision series, the big marathons, etc. The formula revisions, okay? All those things will be discussed here. That's why I would want you guys to subscribe to the channel right now so that you remain updated about all the sessions. Should we start then? All ready? Should we start then, people? All ready for the session? All ready for the session? Let me know once in the chats. All ready for the session? Let me know once in the chats quick. Yeah? All right. Perfect, guys. Amazing. Amazing. The first concept, which is almost asked every year in your NEET examination. I'm going to discuss that topic first. What is that? That is the concept of limiting reagent. This is going to be our concept number 1 that we are going to discuss in the today's session. This particular concept, let me tell you very honestly, almost every year this concept is asked, right? Apart from that, this concept is used in your entire physical chemistry as well. So it is the time to master this particular concept first and do all its question patterns. Point number 1. Okay. Sir, write your Telegram channel name. Let me write it. It is WASSIM BHAT Chemistry Official. Well, I exactly do not remember. Let me first of all check it. What is the Telegram channel name? Sorry for that. It is yes, Wassim Bhat Chemistry Official. This is the name of the channel on which I shall be sharing the handwritten PDF of the today's session. Okay? Perfect. So guys, without wasting a lot of your time, let's get going. Let's get started with the first concept, which is every year asked. Again, I'm repeating the same thing. That is your concept of limiting reagent. So first of all, how do we exactly define the concept of limiting reagent? How do we exactly define the limiting reagent? Please and please take a note of every single thing. Limiting reagent. What is a limiting reagent? How do we exactly define it? Have a look what exactly your limiting reagent is all about. My dear students, let me write few lines on limiting reagent first, then I'll make you understand what this limiting reagent is all about. Point number one. Limiting reagent, I must say, it is that reactant in a chemical reaction. It is that reactant in a chemical reaction which is completely consumed. Which is completely consumed earlier in the reaction. Earlier in the reaction. That's what we call as the limiting reagent. That's what we call as the limiting reagent. Point number one. Point number two, the other reactant. The other reactant, which is not completely consumed. The other reactant which is not completely consumed is what you call as the excessive reagent. You call it as the excessive reagent. Excessive reagent. Point number two. My dear students, point number three. Point number three. Point number three. I'll explain all these points one by one. Entire product formation. Entire product formation is decided by. Entire product formation is decided by the limiting reagent. Entire product formation is decided by the limiting reagent. Point number four. I'll be explaining all these points one by one. When to use the concept of limiting reagent. When to use the concept of limiting reagent. Remember, whenever in a reaction, the amounts of all the reactants are given. Whenever in a chemical reaction, the amounts of all the reactants are given. At that point of time, we use the concept of limiting reagent. Now let's try to understand one by one what exactly these points are all about. Try to understand very carefully, because again I'm telling you the same thing. From every concept, one short question in the NEET 2025 examination. Okay? And you can expect a question from this particular topic as well. Now let's try to understand what this limiting reagent is all about. Try to understand very carefully, guys. Okay? For example, let's say I have got a reaction, a very simple reaction I'm taking. N2 plus H2. Whenever N2 reacts with H2, what does it form? It forms NH3. Whenever N2 gas reacts with your H2 gas, what does it form? It forms your NH3 gas. Okay? My dear students, first of all, let's say this reaction which we have, it is going to be carried out in a container. Right? This is the container in which the reaction is going to carry out. Perfect? This is the reaction in which this is the container in which the reaction is going to be carried out. For example, I'm writing at time t is equal to 0. What is meant by time t is equal to 0? Time t is equal to 0 means the reaction has not started yet. Time t is equal to 0 means reactants have not reacted yet to form the product. Okay, that is time t is equal to 0. Time t is equal to 0 means reaction has not started yet. Reactants have not reacted yet to form the products. Okay. So let's say our time t is equal to 0. We have got some 10 moles each of reactants. Let's say in the container, initially at time t is equal to 0, we have got 10 moles each of reactants. Since the reaction has not started yet, since the reactants have not reacted yet to form the products, so I would say number of moles of NH3 right now in the container at time t is equal to 0. That has to be 0. Because the reaction has not started yet. Because the reaction has not started yet. So my dear students, if you look carefully, I've got a reaction in which N2 has to react with H2 and it has to form NH3. Perfect. It has to form NH3. Now at time t is equal to 0, initially we have 10 moles of this as well as 10 moles of this. But right now, these reactants, they have not started reacting. Therefore, I would say the number of moles of NH3 right now at time t is equal to 0 in the container will be 0. Perfect. Now, my dear students, whenever in a reaction, you are given with the amounts of all the reactants. Whenever in a reaction, you are given with the amounts of all the reactants. As you can see, I'm given with 10 moles of N2. I'm given with 10 moles of H2. Whenever in a reaction you are given with the amounts of all the reactants, at that point of time, we use the concept of limiting reagent. So when to use the concept of limiting reagent? Concept of limiting reagent is used when the amounts of all the reactants will be given to us. Point number 1. Now, in order to use the limiting reagent concept, what are we supposed to do first? We are supposed to balance the reaction first. If I ask you, is the reaction balanced? The reaction is not balanced yet. So let's try to balance the reaction first. This has to be 3 times, this has to be 2 times, and this is 1. So I have balanced the reaction. I have balanced the reaction. The reaction is balanced now. After balancing the reaction, it is the time to check which one is the limiting reagent. It is the time to check which one is the limiting reagent. First of all, before showing you how to identify the limiting reagent, before telling you how to check the limiting reagent, my dear students, you should know first of all what the limiting reagent is. And let me tell you, limiting reagent is that reactant which gets completely consumed earlier in the reaction. When this reaction will start, I would say when the reactants will start reacting and they will keep on forming the product. Okay? When these reactants will start to react, I must say the number of moles of reactants will keep on decreasing. The number of moles of reactants, they'll keep on decreasing. Initially, I had 10 moles of this, 10 moles of this. Now, when the reaction starts, when these reactants start reacting, I would say number of moles of reactants, they will keep on decreasing. They'll keep on decreasing. Among these two reactants, there will be one reactant which gets completely consumed. Among these reactants, there will be one reactant which gets completely consumed earlier in the reaction. You call that reactant as the limiting reagent. So what is the limiting reagent? That reactant which gets completely consumed earlier in the reaction. When the reaction will start, number of moles of reactants will keep on decreasing, right? Among these two reactants, there will be one reactant which gets completely consumed earlier in the reaction. You call that reactant as the limiting reagent. Now, how do we identify among these two reactants which one is the limiting reagent? My dear students, have a look what exactly I'll be doing. Understand. How do we identify the limiting reagent? We have got two reactants. One is N2, one is H2. These are my reactants. What are their stoichiometric coefficients? This is 1, this is 3. How many moles of N2 are we given with? 10 moles. How many moles of H2 are we given with? 10 moles. What I'll be doing? I'll be dividing these moles. I'll be dividing these moles by the respective stoichiometric coefficients. I'll be dividing these moles by the respective stoichiometric coefficients. How exactly? 10 divided by its stoichiometric coefficient. 10 divided by its stoichiometric coefficient. 10 by 1 comes out be 10. 10 by 3 comes out be 3.33. If I ask you, among these two terms, which one is lesser in value? 3.33 is lesser. 3.33 is lesser, right? Perfect. Remember that reactant which gets the lesser value. That reactant which gets the lesser value. That's always going to be your limiting reagent. So among these two reactants, which one is my limiting reagent now? It is hydrogen, which is my limiting reagent. If hydrogen is limiting, what about N2? N2 would be the excessive reagent. Now, my dear students, since hydrogen is limiting, so it would be getting completely consumed. So after some time, when the reaction starts, after some time you will find 0 moles of H2 in the container. After some time, when the reaction starts, you'll find 0 moles of H2 in the container, because H2 is the limiting reagent. It has got completely consumed. No doubt you started with 10 moles, but after some time there will be 0 moles of H2 in the container. There will be no H2 in the container because it has completely consumed in the reaction. It has completely consumed in the reaction. Right? Now, my dear students, since you identified your limiting reagent, now after this, I told you already, entire product formation is decided by the limiting reagent. So H2 is the one which is going to decide the entire product formation. And H2 is going to let us know how many moles of NH3 have got formed and how many moles of N2 would be left in the container when the reaction would have stopped. Now, how this limiting reagent is going to tell us all that? Try to understand. Try to understand, guys. First of all, if I ask you, what is the stoichiometric coefficient of H2? You'll say 3. What is the stoichiometric coefficient of NH3? You'll say 2. So stoichiometry is telling me that 3 moles of H2 gives 2 moles of NH3. 3 moles of H2 gives what? Gives 2 moles of NH3. Stoichiometry is telling me this. This is the information given by stoichiometry. 3 moles of H2 gives 2 moles of NH3. Why am I starting with H2? Because H2 is my limiting reagent. It is going to decide everything. Okay. So if 3 moles of H2 are giving me 2 moles of NH3, if I use the unitary method, 3 moles are giving 2 moles. I'll say 1 mole of H2 would be giving 2 by 3 moles of NH3. Right? 1 mole of H2 would be forming 2 by 3 moles of NH3. But my dear students, if I ask you, did we start with 1 mole of H2 or we started with 10 moles of H2? We started with 10 moles of H2. So my dear students, I would say 10 moles of H2 would have formed 2 divided by 3 multiplied by 10. The value comes out to be 6.66 moles of NH3. So I would say in this particular reaction, how many moles of NH3 have got formed? 6.66 moles of NH3 have got formed at the end of the reaction. This can be your first question. How many moles of NH3 have got formed? You'll say 6.66 moles of NH3 have got formed at the end of the reaction. Perfect. This is your question number 1. Question number 2, they can ask you how many moles of excessive reagent are left in the container. How many moles of excessive reagent are left in the container? Since excessive reagent, it does not get completely consumed. Among these 10 moles, there will be some moles of N2 which would have reacted, but some moles of N2 would be still left in the container at the end of the reaction. How do you check that? How do you check that? See guys, how do you check that? Again, the information will be provided by the limiting reagent. How exactly? See, the stoichiometric coefficient here is 3. Here it is 1. Okay. Now, stoichiometry is telling me that 3 moles of H2, 3 moles of H2 reacts with 1 mole of N2. Reacts with 1 mole of N2. Understand carefully. 3 moles of H2 reacts is the term. 3 moles of H2 reacts with 1 mole of N2. Now you tell me, if 3 moles of H2 reacts with 1 mole of N2, therefore 1 mole of H2 reacts with 1 by 3 moles of N2. Okay, 1 mole of H2 reacts with 1 by 3 moles of N2. But did we have 1 mole of H2 or 10 moles of H2? We had 10 moles of H2. So I would say 10 moles of H2 reacts with 1 by 3 multiplied by 10, which comes out to be 3.33 moles of N2. If I ask you what is this particular term, what is it? I would say these are the moles of N2 which have reacted. These are the moles of N2 which have reacted with what? With 10 moles of H2. So with 10 moles of H2, 3.33 moles of N2 have reacted. Okay. So how many moles of N2 would be left in the container? I started with 10 moles of N2. I started with 10 moles of N2. How many moles of N2 have reacted? 3.33. So how many moles of N2 would be left? 10 minus 3.33. 10 minus 3.33 comes out to be 6.66. So I would say 6.66 moles of N2 would be still left in the container at the end of the reaction. Am I clear with this? Quickly, everybody. Am I clear with this, everybody? Quick. So you got to know the moles of product formed at the end of the reaction. You got to know the moles of excessive reagent also left. Now, my dear students, it is not necessary. They'll ask you the moles of NH3 formed. They can ask you the mass of NH3 formed. They can ask you the volume of NH3 formed. They can ask you the number of molecules of NH3 formed. Since you got the moles multiplied by its molar mass. Moles multiplied by its molar mass will give you the mass of NH3 formed. Moles multiplied by Avogadro's number. Moles multiplied by Avogadro's number will give you the molecules of NH3 formed. And similarly, at STP, moles multiplied by 22.4 liters, that gives you the volume of NH3 formed also. Okay, so it's not necessary. They'll always ask you to calculate the moles. They can ask you the mass, they can ask you the volume, they can ask you the molecules as well. I believe I'm clear. My dear students, I'm quickly summarizing all this. First of all, whenever in a reaction, you will be given with the amounts of all the reactants, you will be using the concept of limiting reagent. In the concept of limiting reagent, the first thing, you're supposed to balance the reaction. After balancing, you're supposed to identify the limiting reagent. How do you identify it? Moles of reactants divided by their stoichiometric coefficients. The one that gets the lesser value, that's the limiting reagent. And limiting reagent is the one that decides the entire product formation. Limiting reagent is the one that decides how many moles of excessive reagent will be left in the container as well. If I'm clear, let me know once in the chats. Let's try to solve certain questions. Quickly, people, if everything is clear, let me know with the fire emojis quick. Then only I'll be showing you some questions so that this concept gets properly clear to you. Is it crystal clear, everybody? I want everyone to say it in the chats. I want the chats to be running continuously today. Because I told you session duration is going to be very short. It's 2.5 hours. Don't worry. Is the concept number 1 cleared? And one more thing. Once we end this session, in the comments, you will be letting me know that concept 1 cleared, concept 2 cleared. For example, concept 3 not cleared, concept 4 cleared, concept 5, let's say not cleared, like that. You let me know in the chat so that I will get to know whether you got all the concepts or not. That too at the end of the session, in the comment section. That's something which I would require from all of you. Perfect. Now, my dear students, one simple question. I believe all of you can easily solve this question. Tell me its answer quickly in the chats. Tell me, everybody. Tell me its answer quickly in the chats. Quickly in the chats. My dear students, as per this particular question is concerned, at time t is equal to 0, we are starting with 3 moles of NaOH and we are starting with 4 moles of H2SO4. So in the beginning, this is 0, this is 0. Perfect. I just have to identify which one is the limiting reagent. How do I identify? Given moles divided by respect to stoichiometric coefficient. So 3 divided by 2 and here 4 divided by 1. 3 divided by 2 is 1.5. 4 by 1 is 4. Which one is getting lesser value? NaOH. So it is NaOH which is my limiting reagent here. Done and dusted. Right? So this question is done. NaOH is my limiting reagent here. Perfect. I believe this is clear. Look at the second question. Look at the second question, people. As far as this particular question is concerned, we are given with a reaction, and that too reaction is given in the balanced format. Look at the reaction. On starting with 2 moles each of reactants. On starting with 2 moles each of reactants. So in the beginning, this will be 0, this will be 0. We have to calculate how many moles of B2H6 would be formed at the end of the reaction. When the reaction would have stopped, at that point of time, how many moles of B2H6 would be there in the container? That is the question. And I believe you can easily kill it. I believe you can easily kill it. First of all, I'm given with the amounts of all the reactants. So which concept I'll be using? The limiting reagent concept. In the limiting reagent concept, the first step is to balance the reaction. The reaction is already balanced. After balancing the reaction, we have to identify the limiting reagent. Which one is limiting? 2 divided by 6, 2 divided by 8. Which one is lesser? 2 by 8 is lesser. The one that gets the lesser value, that is my limiting reagent. So BF3 is my limiting reagent. If BF3 is my limiting reagent, it would have got completely consumed. So 0 moles of BF3 would be left in the container at the end. Now all the product formation is decided by the limiting reagent. Have a look on the coefficient here, it is 8. Have a look on the coefficient here, it is 1. So can I say, as per stoichiometry, 8 moles of BF3, 8 moles of BF3 produces 1 mole of B2H6. Produces 1 mole of B2H6. If 8 moles of BF3 are producing 1 mole of B2H6, therefore 1 mole of BF3 produces 1 by 8 moles of B2H6. Unitary method. Did we start with 1 mole of BF3? No, we started with 2 moles of BF3. So I would say 2 moles of BF3 would have produced 1 by 8 multiplied by 2. The answer is 1 by 4, which is 0.25 moles of B2H6. So I would say finally at the end of the reaction, 0.25 moles of B2H6 would have got formed. Am I clear with this? Am I clear with this? Sir, is this sufficient? This is super sufficient. Don't worry. This is super sufficient. You have got very lesser amount of time left till your NEET 2025. It is better to do the study in the effective way, right? It is better to do the smart work right now. All right? Perfect. Now, guys, one more question. With that, I'll be moving on to the concept number 2. Have a look on this. Have a look on this particular question. Will you be able to solve this? Will you be able to solve this quickly, people in the chats? Will you be able to solve this, everyone? See, guys, if you look at this particular question, on starting with 10 moles each of reactants, we are starting with 10 moles each of reactants. So in the beginning, this will be 0, this will be 0. Calculate the moles of barium phosphate formed. So when the reaction would have stopped, I will have to calculate the moles of barium phosphate that has got formed in the reaction. I'm pretty much sure you can easily solve it. How exactly? First of all, amounts of all the reactants are given. So which concept? Limiting reagent concept. What is my first step? Identify the limiting reagent. So 10 by 3, 10 by 2. 10 by 3 is 3.33. 10 by 2 is 5. Which one is getting the lesser value? BaCl2. So that's my limiting. If BaCl2 is limiting, I'll be left with 0 moles of BaCl2 at the end, right? Okay. Now, my dear students, entire product formation is decided by the limiting reagent. Have a look. The coefficient here is 3. The coefficient here is 1. Perfect. So write one simple statement. Stoichiometry is telling us that 3 moles of BaCl2 gives us 1 mole of barium phosphate, right? 3 moles of limiting reagent are giving us 1 mole of barium phosphate. Therefore, 1 mole of BaCl2 would have formed 1 by 3 moles of barium phosphate. But did we start with 1 mole of BaCl2 or 10? We started with 10 moles of BaCl2. So 10 moles of BaCl2 would be forming 1 by 3 into 10. The value comes out to be 3.33 moles of barium phosphate. So you got to know finally at the end of the reaction, 3.33 moles of barium phosphate would get formed. Am I clear with this? Am I clear with this, people? Everyone in the chats. Is the concept number 1 cleared? Is the concept number 1 cleared, everyone? Is the concept number 1 cleared, everyone? Say yes or no in the chats. I'm moving on to concept number 2. I'm moving on to concept number 2. Tell me quickly in the chats, is the concept number 1 clear? So I'm writing here, concept 1 cleared. If any question is asked from the limiting reagent, you should be in a position to solve that. You should be in a position to solve that. Amazing, guys. Amazing. Amazing. Perfect. Moving on to concept number 2. What is that? Again, the topic which is almost every year asked. From the last 3 years, continuously questions have been asked in empirical molecular formula. And this is the easiest topic among all. This is the easiest topic among all. Okay? This is the easiest topic among all. Have a look what I'll be doing. My dear students, the concept number 2, that is empirical and molecular formula. Okay? Let me make you understand. First of all, do you know glucose? Have you heard about glucose? Absolutely yes. Let me take its example. Glucose. Every one of you would be knowing the formula of glucose, that is C6H12O6. In case of glucose, how many elements are there? There are 3 elements: carbon, hydrogen, oxygen. In case of glucose, there are 3 elements present: carbon, hydrogen, oxygen. Now, if you look at these elements, can you tell me their atomic ratio? It is 6:12:6. This is the ratio here. 6:12:6. Tell me one thing. Can we further simplify this ratio? We can further simplify this ratio. Right? If I divide throughout by 6, it becomes 1:2:1. Okay? So 2 ratios I have with me. 2 ratios I have with me. What do I call this particular ratio? 1:2:1. This is what I'll be calling as the simplest whole number ratio. This is what I call as simplest whole number ratio. This ratio is what I call as the actual ratio. This is the actual ratio of the atoms of different elements in glucose. Actual ratio, simplest ratio. As per the actual ratio, the formula is C6H12O6. As per the simplest ratio, the formula has to be C1H2O1. As per the actual ratio, the formula has to be C6H12O6. As per the simplest ratio, the formula has to be C1H2O1. That formula which gives us the simplest ratio, what do you call that formula as? Empirical formula. That formula which gives me the actual ratio, what do I call that as? The molecular formula. What do I call that as? Molecular formula. So one is empirical formula, one is molecular formula. Right? Empirical formula gives us the simplest whole number ratio, and molecular formula gives us the actual ratio of the atoms of different elements. Right? Now guys, with the help of molecular formula, what can we calculate? We can calculate molecular mass. With the help of molecular formula, we can calculate molecular mass. With the help of empirical formula, we can calculate empirical mass. With the help of molecular formula, we can calculate molecular mass. With the help of empirical formula, we can calculate empirical mass. How exactly? Same. For molecular mass, use the molecular formula. This is the molecular formula. Get the molecular mass. What is the atomic mass of carbon? That is 12. Multiplied by how many carbon atoms? 6. Atomic mass of hydrogen, 1 multiplied by 12 hydrogen atoms. Atomic mass of oxygen, 16 multiplied by 6 oxygen atoms. When you solve this, the value comes out to be 180 AMU, or you can say 180 U. So what is this 180 U? This is the molecular mass of glucose. So tell me, what about the empirical mass of glucose? For empirical mass, I'll be using empirical formula. This is my empirical formula. Carbon, its atomic mass is 12. How many carbon atoms? There's only 1. Plus hydrogen, atomic mass 1, 2 hydrogen atoms. Oxygen, atomic mass 16, there is 1 oxygen atom. When you solve this, the value comes out to be 30 U. So what is this 30 U here? This is the empirical mass of glucose. You understand? One is molecular mass, one is empirical mass. My dear students, once you get the molecular mass and empirical mass, after that, you will be calculating a number which I'm representing with X. You will be calculating a number which I'll be representing with X. What is this X? X is the ratio of molecular mass to that of empirical mass. X is the ratio of the molecular mass to that of empirical mass. For example, if I calculate the X value for glucose, if I want to calculate the X value for glucose, it is going to be equal. molecular mass of glucose divided by empirical mass of glucose. The value comes out to be 60. Sorry, the value comes out to be 6. Right? The value comes out to be 6. So X is nothing, it's a number, which is the ratio of molecular mass to that of empirical mass. Once you get the value of X, remember, once you get the value of X, then you can use this formula. Molecular formula is always equal to empirical formula multiplied by X. So sometimes you will be asked a question where you have to calculate molecular formula, which is how you calculate. First you calculate empirical formula, then multiply that with X. Once you calculate molecular formula, multiply that with X, you'll be getting. Once you calculate empirical formula, multiply that with X, you'll be getting the molecular formula. For example, you can check it for glucose as well. Check it for glucose. What is the molecular formula of glucose? C6H12O6. What is the empirical formula of glucose? C6H2O1. What is the X value of glucose? That is 6. So 6 ones are 6, 6 twos are 12, 6 ones are 6. So LHS is equal. So this formula is absolutely correct. This is one more important thing which I would want you guys to know. Okay? Perfect. Now at the same time, before showing you how to do all this calculation, before showing you how to calculate empirical formula, right? There is one more thing which I would want to tell you. What is that? Remember it directly. Molecular mass, or you can say molar mass, is equal to 2 times the vapor density. Sometimes in the question, vapor density will be given. Sometimes in the question, vapor density would be given. Okay? And from vapor density, you can directly calculate molecular mass, which is 2 times the vapor density. Simple, direct. Okay? Now, my dear students, let's exactly how. Just a second. Let's exactly how a look on the questions which can be asked from your molecular empirical formula. Remember each and everything, whatever I'll be telling you. Okay? Each and everything you'll be remembering, guys. Because the questions you'll be getting from this only, whatever I'll be teaching you. Just a second. Okay. This is your question, for example. This is your question, guys. As far as this particular question is concerned, an organic compound contains, you have got an organic compound that contains carbon, okay, that contains hydrogen, all right, that contains oxygen. You have got some compound which contains these elements. Remember one thing, guys. In the question, 3 things can be given to us. Either I'll be given with the mass percentage of these elements. Remember what I'm saying. Either in the question, I'll be given with the mass percentage of these elements, or in the questions, I'll be given with directly the masses of these elements, or in the question, I'll be given with the mass ratio of these elements. These can be the 3 things which can be given to me in the question. In the question, out of these three things, one thing can be given. Either mass percentage of all, or directly the masses of elements can be given, or the mass ratio of the elements can be given. Now, my dear students, in this particular question, what am I given with? I'm given with the mass percentage of these elements. Perfect. What is the mass percentage of carbon here? That is 38.71%. What is the mass percentage of hydrogen here? That is 9.67%. What would be the mass percentage of oxygen here? It is 100 minus 38.71 plus 9.67. Right? Perfect. In the question, this is the data that's given to me. Mass percentage of carbon is given, mass percentage of hydrogen, therefore mass percentage of oxygen can be calculated. Right? How? 100 minus sum of these two. Okay? Because you know, mass, the sum of mass percentage of all the elements in a compound, that's always equal to 100. So how much this is coming? People are saying 51.6. Okay? I believe you. It is 51.6. Is that? 51.6%. Now, my dear students, the first step which you will be always doing, The first step which you'll be always doing, divide the given mass percentage by the respective atomic masses of the elements. What is the atomic mass of carbon? That's 12. What is the atomic mass of hydrogen? That's 1. Atomic mass of oxygen? That's 16. Right? Divide the given mass percentage by the respective atomic weights. Right? What do I get? I'll be getting atomic ratio here. Right? So it is going to be 38.71 divided by 12, 9.67 divided by 1, and 51.6 divided by 16. What do we get from here? We'll be getting the atomic ratio. If you look at the exact values, the exact values here are coming out to be 3.23. Let me write it. 3.23. This is 9.67. And then it is also 3.23. This is also 3.23. What do I get here? I got the atomic ratio. What do I get here? I got the atomic ratio. Once you get the atomic ratio, remember step by step. Once you get the atomic ratio, then you are supposed to calculate the least atomic ratio. How? Which one is the smallest term out of these three? The smallest term is 3.23. I'll be dividing all these terms with the smallest one. So 3.23 divided by 3.23. That's 1. Okay. 9.67 divided by 3.23. That's 3. 3.23 divided by 3.23. That's 1. Now this comes my least atomic ratio. Least atomic ratio gives me the empirical formula. So what has to be the empirical formula of the compound? It is 1:3:1. So it is 1:3:1. So it is C1H3O1. This is how you calculate empirical formula. I hope I'm clear. First thing, either of these three things will be given. First step, divide them with the respective atomic mass. Right? You'll be getting the atomic ratio. Divide all these things by the smallest term. You'll be directly getting the least atomic ratio. I hope I'm clear. Okay. One more question. With that, the concept is done. Look at this question, guys. Look at this question. You should be able to solve this question on your own now. Have a look. Understand. A compound of nitrogen and oxygen. You have got a compound containing two elements, nitrogen and oxygen. Their mass percentage is given. Their mass ratio is given. How much their mass ratio is given? 7:16. 7:16. Their mass ratio is given. 7:16. 7:16 is their mass ratio. The first step, my dear students, calculate what? Calculate the atomic ratio. How do we calculate atomic ratio? Divide these by the respective atomic masses. So this is 7 divided by 14, right? This is 16 divided by 16. Perfect. This value is coming out to be 0.5. This value is coming out to be 1. You got the atomic ratio. If you got the atomic ratio, what is the next thing? We have to calculate the least atomic ratio. How do you get the least atomic ratio? Which number is smallest here? 0.5. Divide everyone by 0.5. So 0.5 divided by 0.5. 1 divided by 0.5. This value is equal to 1. This value is equal to 2. So the least atomic ratio is coming out to be 1:2. Least atomic ratio means empirical formula. So what is the empirical formula? Empirical formula would be N1O2. This is the empirical formula. But my dear students, if you look carefully, am I supposed to calculate empirical formula or molecular formula? I am supposed to calculate the molecular formula. And I have told you already, molecular formula is nothing. It is empirical formula multiplied by X. Empirical formula we have calculated. What do I need now? I just need X. How do we get the X? I'm asking you. How do we get the X? X is the ratio of molecular mass to that of empirical mass. Is the molecular mass given? No, molecular mass is not given. But vapor density is given. And I have told you already, molecular mass is equal to 2 times vapor density. So 2 into 46 is 92. Right? Divided by. What is the empirical mass? For that, use the empirical formula. So empirical mass is equal to 14 into 1 plus 16 into 2. That is 46U. This is the empirical mass. Right? So the value comes out to be 2. So X value is 2. If X value is 2, I can say your molecular formula is equal to empirical formula which is N1O2 multiplied by X. X value is 2. The value comes out to be N2O4. This is the molecular formula which I was supposed to calculate. If I'm clear to you, let me know once in the chats quickly. If I'm clear to you, let me know once in the chats quickly. Everybody. Tell me in the chats if the concept number 2 is clear or not. Everyone, with yes or no. With yes or no. This was our concept number 2. And now if a question is asked on concept number 2, I'm 100% sure you will be able to kill it. Just remember the process which I'm following. That's it. Just remember the process which I'll be following. That's it. All right. So concept number 2 is clear. I believe. I believe. All right. Let's move on to the concept number 3. My dear students, in the Bohr's model, your concept number 3. In the Bohr's model, we do the calculation of the radius of nth Bohr's orbit. It is a short question. We do the calculation of the radius of nth Bohr's orbit. And people, you must be knowing, for example, let's say I've got an atom. This is its nucleus. Okay. Let's say here you have got some electron. Here you have got the electron. Let's say this atom, it has got the atomic number Z. Z is its atomic number. Z is its atomic number. Let's say this electron is revolving in the shell whose shell number is N. Right? Whose shell number is N. For example, if I ask you, calculate the radius of this nth shell, nth orbit. Calculate the radius here, which you represent with Rn. How do you calculate it? I believe you already would be knowing the formula. If not, remember it. No need to derive it. Radius of nth Bohr's orbit is nothing but R0 n square divided by Z. R0 n square divided by Z. What is the value of R0 here? R0 value is nothing but 0.529 angstroms. R0 is nothing but 0.529 angstroms. Okay. Perfect. Now, my dear students, one more important thing here only. Let's assume this is one atom whose atomic number is, for example, Z1, and the electron is moving in shell number 1. Let's say you've got one more atom. Here, whose atomic number is Z2, and the electron is moving in shell number N2. And the radius of this particular shell here is R2, for example. Let's say this was R1. Now this is R2. I have two atoms, right? Question is asked in which we are supposed to compare these two radii. My dear students, we know radius of nth orbit is directly proportional to n square, inversely proportional to atomic number. So can I say R1 divided by R2? R1 divided by R2 has to be nothing but n1 square divided by n2 square multiplied by Z2 divided by Z1. This is the formula which directly you are going to remember. And from this formula, question will be asked. Okay? From this formula, question will be asked. I'm sure I'm clear with this. Let's exactly see how. Okay? These two formulas are important. Remember them. Let's see how. This was concept number 3. Let's try to apply this concept in the questions. Try to understand very carefully what I'll be doing. I believe this becomes now a chocolate question and you can easily solve it. People, the Bohr's orbit radius of hydrogen atom is approximately 0.529, 0.53. Okay? The radius of the first excited state means n is equal to 2. The radius of the first excited state, right, in angstroms is radius of the first excited state. That means radius of the first excited state. Perfect. How do you calculate radius? R0 n square divided by Z. Perfect. For the hydrogen atom, Atomic number is 1. N value is given to me as 2. The question is done. There is nothing to do here. So it is R naught 0.53 and N square. N ka square is 1 ka square. Sorry, N ka square is 2 ka square. That's 4. Z value is 1. Anything else you have to do here? This is something which I was supposed to calculate. It's a simple, guys. It's a simple one. And I can see majority of the students already gave the answer. What is that? It's 2.12. Nothing you have to do here. Nothing you have to do here. And these are the questions asked. These are the questions asked, people. Okay, let's do one more. Let's do one more. Let's do one more. The question was asked in your NEET 2022 as well. Have a look. Have a look. If the radius of second Bohr's orbit of He positive is this, what will be the radius of the third Bohr's orbit of Li positive? Li positive. These are the two ions which are given to me. One thing, guys. Let me represent this by number 1. Let me represent this by number 2. I'm representing this by number 1, this by number 2. Okay? If the radius of second Bohr's orbit means N value here is 2. Of He positive, hydrogen, helium, its atomic number will be 2. Helium is atomic number 2. Let's say its radius is R1, which is given to me as 105.8 picometers. What will be the radius of third Bohr's orbit? Third Bohr's orbit of Li positive, hydrogen, helium, lithium, right? So Z is 3 here. So let its radius be R2, which is to be calculated. Perfect. Now, my dear students, which formula I'll be using? Few minutes back only I've given you one formula. What is that? R1 divided by R2 is equal to N1 square divided by N2 square multiplied by Z2 divided by Z1. What is the value of R1? R1 value is 105.8. R2 I have to calculate. N1 ka square. So 2 ka square is 4 divided by N2 square. 3 ka square is 9. Z2 is 3. Z1 is 2. Right? So from this particular equation, can't you calculate the value of R2 by just cross multiplying? Right? And final answer you'll be getting as option 1. Final answer you'll be getting as option 1. I hope I am clear with this question as well. Okay? And I hope you are clear with it too. One more question, people. One more question. Solve it right now quickly. I'm giving you just 1 minute of time. Simple question this is. Again the basic question. Quickly, everybody. Quickly, everyone. Guys, it's a simple question. Done? I hope you would have easily solved this. The answer is 8:9. So which concept this was? This was concept number 3. Now, my dear students, concept number 4. Concept number 4, which is again frequently asked. Concept number 4, which is again frequently asked. That is velocity of the electron in the nth Bohr's orbit. Okay? For example, you have got the atom whose atomic number is Z. Okay? This is the electron revolving here in the shell number n. And this electron is revolving with the velocity Pn. How do we calculate the velocity of the electron moving in the nth Bohr's orbit? How do we calculate the velocity of the electron in the nth Bohr's orbit? Do you remember the formula? Do you remember the formula? velocity of the electron in the nth Bohr's orbit is equal to V naught Z by N. V naught Z by N, right? Okay. And when you have to compare, okay, one more thing. What is the value of V naught? It is 2.16 into 10 raised power 6 meter per second, right? 2.18 it is. 2.18 into 10 raised power 6 meter per second. That is the V naught value. Remember this as well. And when you have to compare the velocities of electrons moving in two different orbits, what is the formula which I'll be using? Simply V1 divided by V2 is equal, it is Z1 divided by Z2, and this is N2 divided by N1. Perfect. So any question based on these two formulas, you can easily solve. I believe that. For example, see, one simple and basic question this is. Calculate the velocity of the electron placed in the second orbit. Placed in the second orbit of Li di positive. So you are given with Li di positive ion. Li di positive ion, right? Its atomic number, hydrogen, helium, lithium, 3. Okay. N value. Placed in the second orbit. N value is 2. I have to calculate velocity. V is equal to V naught. Z divided by N. V naught is 2.18 into 10 raised power 6 meter per second. Z value is 3. N value is 2. Just the matter of calculation, right? Just multiply, divide, get the answer in meter per second. A simple basic question. Again, this is. Am I clear? A lot of students have already given the answer. The answer of this question will be this one. Perfect, guys. Am I clear with this? Tell me quickly in the chats. Am I clear with this? Am I clear with this? Right? Okay. If you are clear with this, one more question. And after that, we'll discuss one more concept. These are small concepts only. These are small concepts only. If the velocity of the electron in the first orbit of hydrogen is V, what will be the velocity in the third orbit of Li di positive? These are the two things which are given to me. I'm calling this as 1. I'm calling this as 2. Simple. Calling this as 1, calling this as 2. Tell me one thing. If the velocity of the electron in the first orbit means N1 is 1 here, right? First orbit of hydrogen. For hydrogen, atomic number is 1. And velocity, V1 is given as V. Okay. What will be the velocity V2? What will be the velocity V2 of the electron in the third orbit? In the third orbit of Li di positive. Hydrogen, helium, lithium. Okay. Which formula I'll be using, 1 or 2? Second one. Simple, guys. So I'll be just writing V1 divided by V2 is equal to Z1 divided by Z2 multiplied by N2 divided by N1. This is the formula. Now, V1 is V, V2 I have to calculate is equal to Z1 is 1, Z2 is 3, N2 is 3, and N1 is 1. So this got cancelled. So I can directly say V2 is equal to V. Simple question this is. V2 is equal to V. These sort of questions also you get in your exam. I hope I'm clear. Perfect. So which concept this was? Concept number 3 or 4? This was our concept number 4. Okay, concept number 4. Similarly, my dear students, concept number 5. Concept number 5 here. Concept number 5. What is it? That's question based on the time period. First of all, before showing you this, let me know in the chats if all the things are clear. Quickly. Quick, everybody. Yeah? My dear students, the next concept, that is concept number 5. As I've told you, don't worry. We are going to discuss some 10 concepts only today. Okay, don't worry. I'll be completing all the 50 topics in 3 to 4 sessions. So, all things are clear till here. Now, moving on to concept number 5. That is the question based on time period. How do you calculate time period of the electron moving in the nth Bohr's orbit? Matlab, if this is, for example, the nucleus, right? This is the electron here. Atomic number of the atom is Z, right? This is the electron moving in the nth Bohr's orbit, right? How much time this electron will take to complete one revolution? How much time this electron will take how much time the electron will take to complete one revolution. That is the time period. And time period formula, everybody remember from now onwards. It is T naught n cube divided by z square. Time period of the electron in the nth Bohr's orbit is equal to T naught n cube divided by z square. Okay. Now, my dear students, how do you compare the time period of two electrons? How do you do that? Simple. T1 divided by T2 has to be equal to N1 cube, N2 cube, right? Z2 square, Z1 square. Perfect. This is how you compare the time period of two electrons moving in two different Bohr's orbits. Moving in two different orbits. One more thing. What is the value of T naught? 1.5 into 10 raised power minus 16 seconds. This is the value of T naught. This is the value of T naught. Guys, if any question comes from this, will you be able to solve this? The question format is going to be same as what we have done in your radius and velocity. See, out of 1, 2, 3, 4, 5, 6, 6 terms are here. Out of 6 terms, 5 will be given to us. We'll have to calculate the 6th one. Okay? From this particular formula, only question will come. Out of these 6 terms, 5 will be given and 1 will have to calculate. So I'm not going to waste a lot of time here. Okay? There is much more important one, that is calculation of spectral lines. This is concept number 6. This is our concept number 6. From this question is asked. Okay? What this concept number 6 is, try to understand people what I'll be saying. This is important and almost every year question is asked. Okay? Have a look. Understand what I'll be saying. Understand what I'll be doing. My dear students, the first question that is asked on the calculation of total number of spectral lines. Calculation of total number of spectral lines. One simple formula I'm giving you. N2 minus N1. N2 minus N1 plus 1 divided by 2. You are first of all going to remember this formula. What is N1 here? What is N2 here? And how do we apply it? See, N1 represents the lower energy state. N2 represents the higher energy state. Higher energy state. Now see what is to be done. Try to understand very carefully. My dear students, for example, this is shell number 1, in which electron is present. For example, try to understand properly, guys. This is shell number 1. Let's say this is your shell number 2. Let's say this is your shell number 3. Okay. Let's say the electron is present in shell number 3. Let's say the electron is present in shell number 3. For example, electron has to come from 3 to 1. Electron has to come from 3 to 1. And you know, when the electron makes a transition from higher energy state to lower energy state, it emits energy. It emits energy in the form of radiation. In the form of radiation. It emits energy in the form of radiations. So electron has to come from 3 to 1. Now, can you tell me how many ways are there for the electron to reach from 3 to 1? First thing. Electron can directly jump from 3 to 1. Correct? Electron can directly jump from 3 to 1. And if the electron moves from 3 to 1, higher to lower, it emits a radiation. This is the radiation which it has emitted. Is there any other possibility for the electron to go from 3 to 1? Yes. Electron can first go from 3 to 2 and then from 2 to 1. 3 to 2 means 1 radiation. 2 to 1 means 1 more radiation. Okay. So how many radiations in total electron is emitting? 3. Right? This is the first one. This is the second one. This is the third one. Is there any other way? I don't think there is any other way. So in total 3 radiations. So how many spectral lines? How many spectral lines we got? We got 3 spectral lines. Okay? It looks easy to you by solving it like this. But imagine the question is asked, electron is making a transfer from 10 to 1. How many total spectral lines will be observed? There you cannot use this. You can use, but it's going to take a lot of time. So therefore, I'm giving you this formula. See guys, calculation of total spectral lines. Total spectral lines is equal to N2 minus N1. N2 is the higher energy state, N1 is the lower energy state. Higher energy state here is this. This is the higher energy state. Its value is 3. Lower energy state, its value is 1. Okay, so N2 minus N1. N2 minus N1. N2 minus N1 plus 1 divided by 2. This one cancel. 3 2s are 6. 6 divided by 2 is 3. So answer again, you got 3 only. Answer, you got 3 only. Simple. Is it clear? This formula directly from this formula question is asked. Directly from this formula question is asked. Okay. Perfect. Now guys, one more thing which I'm giving you here. One more thing. This was the formula to calculate total spectral lines. Now, number of spectral lines falling in a particular series. For number of spectral lines falling in Lyman series, number of spectral lines falling in Balmer series, number of spectral lines falling in Paschen series. That can be one more type of question asked, which I'll tell you in some time. First of all, remember the formula. It is simply N2, higher energy state, minus ground state of the series. Ground state of the series. Try to understand what this formula is. This again important one which is asked. Okay. See guys, for example, I'm asking you a question. Let's say the electron is making a transition from 6 to 1. Let's say the electron is making a transition from 6 to 1. This is the lower energy state. This is the higher energy state. Lower energy state, higher energy state. First of all, let's try to calculate the total number of spectral lines. So total spectral lines is equal to N2 minus N1. N2 minus N1. N2 minus N1 plus 1 divided by 2. So this term cancel. 6 5s are 30. 30 divided by 2 is 15. So in total, how many spectral lines will we be getting? We will be getting 15 spectral lines. Now, out of these 15 spectral lines, how many will fall in Lyman? How many will fall in Balmer? How many will fall in Paschen? So, number of spectral lines out of these 15, which will be falling in Lyman, it is equal to N2 minus ground state of Lyman. N2 here is 6. What is the ground state in Lyman? In Lyman, the ground state is 1. So 6 minus 1 is 5. So out of 15, 5 spectral lines will fall in Lyman series. How many spectral lines will fall in Balmer series? N2, that is 6. In Balmer, the ground state is 2. 6 minus 2 is 4. Correct? Right? How many spectral lines will fall in Paschen? 6 minus 3 is equal to 3. Lyman, Balmer, Paschen, bracket 2, fund. Do you understand? If you do the addition of all this, 4 plus 5 plus 3 plus 2 plus 1, it will come out to be 15. So total there were 15 spectral lines, out of which 5 will fall in Lyman, then Balmer, then Paschen, bracket fund. Remember, question will be asked from this as well. Question will be asked from this as well. Am I clear to everyone? Am I clear to everyone? Am I clear to everyone? This particular table also you will be remembering. Also, okay? All the Lyman series will fall into ultraviolet region. Balmer series, visible region. Paschen, infrared, infrared, infra. So U, V, I. Okay? From this table, question has been asked once. Okay? It can be asked too. This is important. Perfect. Balmer series fall into which region? It falls into visible. Bracket series falls into which region? Infrared. Okay? Remember this particular table as well. This is important. This is important. U, V, I. I hope I'm clear to everyone. And my dear students, if I'm clear to everyone, there is one simple question which I'm asking you. The question is asked in NEET examination long back. In which of the following series of transition in the spectrum of hydrogen falls in visible region? Which one falls in visible? Tell me quick. U, V, I. Lyman, Balmer, Paschen, bracket. U, V. Visible means Balmer. Right? Clear? See what kind of question was asked long back in your NEET examination. You can kill this. And guys, from this you are understanding the level of your NEET as well. Okay, so don't worry. The question paper is going to be easy only. Not very difficult. you will be able to kill each and every question. Electron is excited from ground state to the fifth orbit. The number of spectral lines. Electron was earlier in ground level. So ground state is, lower energy state is 1. Higher energy state is 5. So N2 minus N1. N2 minus N1 plus 1 divided by 2. So 5 4s are 20. 20 divided by 2 is 10. So in total, 10 spectral lines are observed. Now out of 10, how many will fall in Lyman? How many will fall into bracket, Paschen, etc., etc.? That is something which you can easily calculate now. I hope I am clear with this. So this was our concept number 6, my dear students. Concept number 7. This is super important, right? Concept number 7, which is super important, guys. Questions will be asked from this as well. Questions will be asked from this as well. Probability distribution curves. There are 2 things given in your syllabus. First one, psi square versus R. Psi square versus R for 1s and 2s. This is asked in your syllabus. Second, psi versus R for 1s and 2s. Out of this, anything can be asked. Let me show you how to deal with all this. A lot of students find it tough, but this is not. It is not. It is not. Someone is saying, sir, you're not good in this dress. Are you sure? Should I again keep on wearing the jackets which I used to wear? For the first time, I'm wearing some t-shirt, at least. Okay? For the very first time in my life, I'm wearing the t-shirt. Yeah? Okay, nice or not nice? Tell me in the chats. I'll follow you guys only. Quick. Quickly. Okay. So from this t-shirts and all, I can show the biceps, you know, the tricep cuts and all. So you have to sometimes show this too in the live session, yeah? Right? You should know you have got the handsome teacher teaching you all the time. Correct? Chalo, let's move on. Let's move on. Let's move on. Chalo, this is our concept number 7, guys. And please try to understand it very, very, very carefully. Okay, very carefully you are going to understand. Very carefully you are going to understand this. Okay, be careful with what I say. First of all, guys, we have got the topic that is calculation of nodes here. Calculation of nodes. Okay, calculation of nodes. Now, there will be a direct question in which you will be asked to calculate total number of nodes. Remember first of all what I say, and I'll show you its application in some time. Total number of nodes are calculated by the formula n minus 1. This is the formula with the help of which we calculate total number of nodes. I'll show you its example in some time. First of all, remember. Now, nodes here are basically of 2 types. Nodes are basically of 2 types. One is what I call as radial, or you can call them as spherical nodes. Radial or spherical nodes. One is what you call as angular nodes. Radial or spherical nodes. Number 2 is the angular nodes. How do I calculate the total number of radial or spherical nodes? Given by the formula n minus L minus 1. How do you calculate the angular nodes? Given by the formula L. L is the azimuthal contour number. Okay. Now, first of all, understand and remember. For the S subshell, what is the value of L? L value is 0. For P, the value of L is 1. For D, the value of L is 2. Right? For F, the value of L is 3. Certain things to be remembered. Okay. Certain things to be remembered. Now, my dear students, one more thing. Remember directly. Remember directly. I'm just giving you the tricks to do the questions, right? Tricks to do the questions. Remember, in case of s orbitals, psi versus r and psi square versus r. In case of s orbitals, psi versus r and psi square versus r. In the graph, they start from the top. They start from the top. First of all, remember all these things. You'll see how easily you are going to draw the graphs. Okay, start from the top. In case of your p orbitals, your psi versus r and psi square versus r, they start from the bottom. Okay, now see how exactly I'm going to make you explain all of this. Try to remember and understand each and everything what I'll be saying. For example, I've got 1s here I've got 2s, here I've got 3s, here I've got 4s, here I've got 5s. Try to understand carefully what I'll be saying. In the syllabus only 1s and 2s is given, but I'm showing you all of them. Okay. First of all, in case of 1s, what is the value of n? Principal quantum number, that's 1. L value for s, that is 0. Okay. Perfect. How many total number of nodes are there? Total number of nodes. N minus 1. Total number of nodes. N minus 1. 1 minus 1 is 0. So there is no node. Correct? Right? Now, here, if I want to draw psi versus r, or I want to draw psi square versus r. Okay? Since I'm talking about s, for s, your psi versus r and psi square versus r, they start from the top. So they start from the top, like this. But it won't touch the r-axis. Because if it touches the r-axis, that point represents the node. If it touches the r-axis, that point represents the node. But in case of 1s, is there any node? There is no node. So it does not have to touch the r-axis. Similarly, take the same replica of this graph and keep it like this. Okay? Perfect. Now guys, go to 2s. Things will get clear slowly. N value here is 2. L value here is 0. N value 2, L value 0. Okay. Tell me how many total number of nodes. N minus 1, 2 minus 1, that's 1. Total number of node is 1. You've got one node. Now, which node is it? Is it radial or angular? Let's calculate the radial nodes. Radial nodes is given with the formula n minus L minus 1. So 2 minus 0 minus 1. The value comes out to be 1. So this one node is basically radial node. So is there any angular node? Angular node is given by the value of L. L value is 0. No, there is no angular node. So you got to know one thing. There is one radial node, 0 angular nodes in case of 2s. Now see. Now guys see. This is psi versus r. And here I'm writing psi square versus r. Since I'm talking about s, for s the graph is going to start from the top. Okay, it's going to start from the top. Is there any node? There is one node. There is one node. So the graph is going to touch the r-axis at one point. So it goes down like this, and this point represents your node, radial node. Perfect. Psi value can be positive as well as negative, but psi square is always positive. Psi square is always positive. Remember, psi square is always positive. Psi value can be positive or negative. So, in order to make psi square versus r, what you need to do, that portion of the graph that is down the r-axis, that means I'm talking about this part. Remove this part and take its image over here. So, I'm getting something like this. Here, then remove this part and take its image. Its image is going to be like this. And this point represents a node here. Perfect. This is psi square versus r graph here. Am I clear? Am I clear, people? Am I clear? These are S curves which I'm showing you. I'll be showing you P curves as well. Simple. Oh, we have got HSP Baba in the chats. Welcome, Paji. Welcome, sir. How are you? Long time no see. No calls, no messages, nothing. Yeah, where are you? Where are you? Get ready for the session. You have to take one session in this series as well. Okay? HSP, sir. Best teaching, bro. Thank you so much, sir. Thank you so much. Shukriya. Well, I'm not teaching this in detail. I'm just giving them the tricks to remember each and everything of this. Otherwise, you know how difficult it is in reality. Yeah. Wasim sir says something in Tamil. HSP Baba, nalla irka. HSP var nalla irka. Yeah. I think that's good, huh? HSP Baba nalla irka. HSP Baba teaches nalla irka. Is that good? Is that good? Yeah. What is the meaning? Meaning is HSP sir teaches very good. Meaning is HSP sir teaches nalla irka. That means it is very good. Okay. Now sir has started saying Romba Sulbam. What is that? I don't know. Sir, Kashmiri में कुछ once a Kashmir पर क्या बोझन? Iman कहती है Kashmir समझ. उस Kashmir channel अक्ष जरूरी खोलिन. यास मस Kashmir पर पढ़ना NEET, huh? Guys, did you understand what I said? I said all the people here, they won't be able to understand Kashmiri. I think I will start a Kashmiri channel too, wherein I'll be training students in the Kashmiri language. All right. Perfect, perfect. Let's move on. Now, talk about 3S. Guys, don't get deviated. HSP sir has come to distract us. Okay? We should not get distracted. We won't let HSP sir to distract us. All right? Chalo. In case of your 3S. See guys, in case of your 3S, first of all, tell me one thing. What is the n value here? N value here is 3. What is the value of S? I mean, L value for S, that's 0. How many total number of nodes are there? N minus 1. 3 minus 1, that's 2. And both these nodes would be radial nodes. N minus L minus 1. N minus L minus 1. So both these nodes are radial nodes. So there is no angular node here. Now, first of all, I have to make two graphs here. One is your psi versus R. And one more is your psi square versus R. Perfect. For S, the graph starts from the top. Okay. Now, there are two nodes. Perfect. So, the graph has to touch the R axis at 2 points. This is 1 point. Just a second. This is 1 point. This is the second one. So these are your two radial nodes here. Perfect. These are the two radial nodes. Now, psi square versus R. Is there any part of this particular graph down the R axis? Yes, this particular part is down the R axis. So remove it and take the reflection. So psi square versus R will be like this. From here to here, it's same. Now, this particular part, its reflection was supposed to be taken. After that, it's same. 1, 2, two nodes here, two radial nodes. Clear? 4S you can easily make, right? N value here is 4. L value is 0. Total number of nodes is 4 minus 1, that's 3. And all these 3 nodes are the radial nodes. So there will be no angular node because L value is 0. Perfect. If you want to draw a graph, you can easily do that. First of all, psi versus R. The second one is your psi square versus R. At how many points the graph will touch? 3 points. S graph, so start from the top. So 1, 2, 3. Okay, 1, 2, 3. Now, this portion, right? Take the reflection. 1, 2, 3, and like this. 1, 2, 3. 3 radial nodes. Perfectly done. Perfectly done, people. Perfectly done. From this question will be asked. So remember it. So remember it from now onwards. I hope I'm clear to every one of you. I hope I am clear to every one of you. Perfect, guys. I hope it's clear. Now, do you want to see the P curves as well? But P is not in your syllabus. P is not in your syllabus. Let me tell you that honestly. In your syllabus, clearly they have mentioned 1s and 2s. Okay? 1s, 2s, they have clearly mentioned. I think let's not waste our time for the P. Okay? Perfect. Great. Now 5s you can easily draw it. Perfect. There will be 4 nodes in total. The graph will be touching at 4 points. So this was my concept number 7. Concept number 7. Tell me the answer of this question. Psi square versus r is given. The graph is starting from the top. And when the graph is starting from the top, that means it's the graph for S. And if it is for S, there is one node only. It is touching only at one point. There is one node. There is one node. One node is for which one? One node is for which one? That's for 2s, right? So this graph is valid for 2s. Okay, just remember in case of P, the psi square versus r and psi versus r, they start from the bottom. For example, I'm making a graph like this. The graph is starting from here. Let's say it's like this. This is psi square. This is r. Perfect. First of all, the graph is starting from the bottom, so it's P. It's P first of all. Now, how many nodes? 1, 2, 3. 3 nodes in total. So total nodes are 3. Total nodes means n minus 1. N minus 1 total nodes is equal to 3. So n is equal to 4. So this graph is for 4p. Simple. Okay? Got it? For example, you have a graph like this. Psi versus r. Okay? Psi versus r. So first of all, the graph is starting from the bottom, it's P. Now how many nodes? 1, 2, 3, 4, 5. 5 nodes in total. So total number of nodes is n minus 1, that's 5. So n value here is 6. So 6p. Simple. Okay, I believe this is clear. I believe this is clear. Now some Einstein has come. Sir, please teach difficult topics. Have you understood this topic? Have you understood this topic? Some Einstein has come in the chats. Have you understood this topic before? If you have understood, can you tell me whether this is correct or not? This is psi, this is r. Is this correct or not? Mr. Einstein? Focus on what I do. Okay? I'm your father's age. I know like what comes, what does not come. Let's move on. So this was your concept number. This was your concept number 7. Now concept number 8, which I'll be discussing, that is again important. Concept number 8. Concept number 8. Okay, concept number 8 is related to Lewis structure and formal charge. This is also asked frequently. Lewis structure and formal charge. This is our 8th concept of the today's session. Okay, and let me show you all of this in detail. Right? Have a look, people. What do I do? No, I'm not of his father's age. It's okay. That was just simply. Understand, guys. Lewis structure and formal charge. This again one important topic from which question is asked. Okay, have a look. For example, I'm taking a molecule Cn negative. I'm taking an ion Cn negative. Okay, I have to draw its I have to draw its structure first of all. I have to calculate the formal charge, etc., etc. How do we do that? I'll show you two, three examples. All of this will be clear. Understand. Cn negative. Cn negative. First of all, if I ask you, how many valence electrons are there with carbon? 4 valence electrons with carbon. How many valence electrons are there with nitrogen? 5. Is there charge? Yes, negative. If there is negative charge, add that. Adding 1. Adding 1. Okay, adding 1. Now have a look. 5 plus 4, 9, 9 plus 1, 10. So how many total valence electrons? Total 10 valence electrons. If there are total 10 valence electrons, so tell me, how many valence electron pairs? 10 valence electrons means 5 valence electron pairs. 10 valence electron means 5 valence electron pairs. Okay. Now people, since we have 5 valence electron pairs, so write carbon and nitrogen here. Written. Okay. Put a single bond first of all. Done. Single bond means 1 electron pair. Single bond means 1 electron pair. So out of 5, I have used 1 electron pair. Out of 5, I have used 1 electron pair. How many electron pairs are left? 4 electron pairs are left. 1 electron pair I have used. 4 are left. 4 are left. 4 are left. Okay. Now, my dear students, which atom is more electronegative here? Carbon or nitrogen? Nitrogen is more electronegative. So start filling the octet of nitrogen. Have a look. Nitrogen already has 2. 4, 6, and 8. So octet of nitrogen is complete. Total, I had 5 valence electron pairs, out of which I have used 1, 2, 3, and 4. 4 I have used. 1 is left. So give that one to carbon. So I have used all the 5 valence electron pairs. But now check. Octet of nitrogen is complete. But is the octet of carbon complete? No. Octet of carbon is not complete. So try filling the octet of carbon. Say, remove the lone pair from here. Put a bond. Okay. Octet of nitrogen is still complete. 1, 2, 3, 4, 5, 6, 7, 8. Octet of nitrogen is complete. But carbon, 2, 4, and 6. No. Remove one more and put a bond. So this is your Lewis dot structure. Okay. This is your Lewis dot structure. Perfect. Now, my dear students, how do you calculate formal charge on these atoms? How do we calculate formal charge on these atoms? Formal charge on carbon, first of all. Formal charge on carbon. My dear students, tell me one thing. In case of carbon, when carbon is in non-bonded state, when carbon does not form any bond, at that point of time, how many valence electron carbon has? Carbon has 4 valence electrons. Carbon has got 4 valence electrons. Okay. Right now in bonded state, how many valence electrons it has? 1, 2, just count one of it, one of it, one of it. So it's 5. 4 minus 5 comes out to be minus 1. So formal charge on carbon is minus 1 here. Formal charge on carbon is minus 1 here. Now what about nitrogen? When nitrogen is in non-bonded state, it has got 5 valence electrons. Minus. Right now, how many it has? 1, 2, 3, 4, 5. So 5 minus 5 comes out to be 0. So formal charge on nitrogen is 0. Okay. Perfect. Am I clear? Am I clear? Am I clear? Let me take one more example. With that, every single thing will be clear. Because the questions are asked from this as well. For example, you have got CO3 dinegative. CO3 dinegative. We have to draw its Lewis dot structure as well as the formal charge of the atoms. Okay? Okay? Try to understand, guys, what I'll be doing. First of all, calculate the total valence electrons which we have. Carbon has got 4. Oxygen has got 6. There are 3 oxygen atoms. And there is dinegative. So add it. So this is 4 plus 6 3s are 18 plus 2. The value comes out to be 24. There are 24 valence electrons in total. There are 24 valence electrons in total. So how many valence electron pairs will be there? 24 by 2 means 12 valence electron pairs are there. Total, there are 12 valence electron pairs. Now, carbon and 3 oxygen atoms. Which one is less electronegative? Carbon is less electronegative. The one that is less electronegative, that has to be kept at the central atom. So this is carbon, the central atom. And there are 3 oxygen atoms like this. Okay. Carbon, with carbon we have got 3 oxygen atoms. Now I have got in total 12 valence electron pairs. Put one bond here, one bond here, one bond here. So how many I have used? I have used 3. How many are left? 9. 9 are left. Which one is more electronegative? Oxygen. Right? Start filling the octet of oxygen. So 2, 4, 6 and 8. 2, 4, 6 and 8. 2, 4, 6 and 8. So how many valence electron pairs I had in total? 12. Out of 12, how many I have used? 1, 2, 3. 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 3 is 12. I have used all the 12 valence electron pairs. No doubt, octet of oxygen is complete. Octet of this oxygen is complete. Octet of this oxygen is complete. But is the octet of this carbon complete? Check it out. Is the octet of this carbon complete? Octet of carbon is not completed yet. Okay? Octet of carbon is not complete yet. So what do I need to do? It has got 2, 4, 6. 6 valence electrons. How many it needs? 8. So out of any oxygen, remove one of the lone pair. For example, you are removing one lone pair here. And instead of this lone pair, put a double bond. So what did I do? Put a double bond. Octet of this oxygen is also complete. Octet of this carbon also got completed. Okay? So this is. Now it's not necessary that you will remove from here only. You could have removed from here. Put a double bond here. You could have removed from here. Put a double bond here. Now, my dear students, just tell me the formal charge. What is the formal charge of this oxygen? Oxygen in non-bonded state has got 6 valence electrons. Minus. Right now, how many it has? 1, 2, 3, 4, 5, 6 and 7. 6 minus 7 comes out to be minus 1. Okay. Here also. 6 minus 7 comes out to be minus 1. If you check here, non-bonded state 6 minus right now 1, 2, 3, 4, 5, 6. 6 minus 6 is 0. So you got the formal charge of each atom here. Okay. That's what you do. Okay. Right? Am I clear with this, people? Quickly in the chats. Everybody. Everybody, people. Everybody. Everybody in the chats. Is it clear? So till now, how many concepts done? 8 concepts are done till now, right? 8 concepts are done till now. Now the 9th one. Now the 9th one. That is how to calculate hybridization. This is very, very, very important, and understand what I'll be doing here. Understand what I'll be doing here. From hybridization, every year question is asked. Okay? From hybridization, every year question is asked. Harshit is saying, no respect for students. Bro, no respect for students like you. Okay? Perfect. Don't mess in the chats, you'll be blocked. Perfect. Right? I was teaching one of the very, very important concepts which is asked in the exam, and you are writing in the chats Dabba concept. Is that Dabba concept? Do you know what is psi, what is psi square? Nobody teaches you that on YouTube, first of all. Okay? So no respect for students like you. Not to everybody. Have a look on how to calculate hybridization. All right. So people, first of all, understand and remember. Understand and remember what I say. There's a method called as steric number method. There is a method called as steric number method, with the help of which we calculate hybridization of different atoms. And how do we exactly do it? Understand what I say. First of all, steric number is nothing but, that is defined as sigma plus lone pair. Steric number is defined as sigma plus lone pair. First thing, steric number is defined as sigma plus lone pair. My dear students, remember, if the steric number comes out to be 2, remember, if the steric number comes out to be 2, hybridization involved is going to be sp. If the steric number comes out to be 2, hybridization involved is going to be sp. The geometry predicted through hybridization is going to be linear. If the steric number comes out to be 3, how to calculate steric number? I'll show that in some time. First of all, remember what I say. Okay. If the steric number comes out to be 3, hybridization involved is sp2, and it's going to be triangular planar. The geometry involved is triangular planar. If the steric number comes out to be 4, hybridization is sp3. The geometry involved is tetrahedral. Remember all this first of all. If the steric number comes out to be 5, hybridization involved is sp3d. The geometry involved is trigonal bipyramidal. Trigonal bipyramidal. Okay. If the steric number comes out to be 6, hybridization involved is sp3d2, and geometry involved is octahedral. If the steric number comes out to be 7, hybridization involved is sp3d3. The geometry involved is pentagonal bipyramidal. Pentagonal bipyramidal. Remember, in case of sp3d hybridization, it is going to be dz square, which is involved in the hybridization here. In case of sp3d2, it is dxy and it is dx square minus y square and dz square. These two d orbitals, they participate in the hybridization. In case of sp3d3, it's going to be dx square minus y square, it's going to be dz square and dxy. These 3d orbitals, they participate in the hybridization. Remember these things first of all. And once you remember all this stuff, now it's going to be pretty much easy. We just need to know how to calculate steric number. Once we get the steric number, we can talk about hybridization, we can talk about geometry, we can talk about which d orbitals are involved in the hybridization, everything. Now have a look. So what is the last one? Last one is pentagonal bipyramidal. And this is here, dx square minus y square, dz square and dxy. Okay. Now try to understand how do we calculate steric number and how do we talk about the geometries and stuff. See, let me take a lot of examples first of all here. The simplest with I'll be starting is CH4. Let's say you have got NH4 positive. Let's say you have got XCF4. Let's say you have got I3 negative. Let's say you have got ClF3. Let's say you have got SF4. Okay, perfect. Let's try to calculate each of the things in these examples so that you can understand them properly. First of all, in case of CH4, which is the central atom is carbon. Central atom is carbon. How many valence electrons carbon has? 4 valence electrons. Point number 1. 4 valence electrons. How many surrounding atoms are there? 4. Remember, the number of surrounding atoms is equal to the number of sigma bonds. Number of surrounding atoms is equal to the number of sigma bonds. Okay, 4 surrounding atoms, 4 sigma bonds. So carbon is forming 4 sigma bonds. Carbon had 4 valence electrons. Carbon had 4 valence electrons. And carbon is utilizing all these 4 electrons to form 4 sigma bonds. Carbon had 4 valence electrons and carbon is utilizing all these 4 valence electrons to form 4 sigma bonds. So will there be any lone pair on carbon? 0 lone pair. Sigma 4, lone pair 0. Steric number 4 plus 0 is 4. And when the steric number is 4, hybridization involved is sp3. Done? Clear? Talk about NH4 positive. Talk about NH4 positive. Nitrogen. How many valence electrons it has? 5. But there's a positive charge. If there is positive, subtract that. If there is negative, add that. So positive means subtract that. So 5 minus 1 is 4. How many surrounding atoms? 4. 4 valence electrons. Utilized all the 4 to form 4 sigma bonds. No lone pair on nitrogen. Steric number 4 plus 0 again is 4. Hybridization involved is sp3 here. Right? Simple. And sp3 means tetrahedral geometry. sp3 means tetrahedral geometry. Simple. XeF4. XeF4. Xenon. Xenon, my dear students. Xenon has how many valence electrons? Xenon is a noble gas, right? How many valence electrons? 8 valence electrons. How many surrounding atoms? 4 surrounding atoms. So 8 valence electrons, 4 sigma bonds. So out of 8 valence electrons, 4 valence electrons are used to form 4 sigma bonds. So 4 more are left as such in the form of 2 lone pairs. There are 2 lone pairs on xenon. Steric number 4 plus 2 is 6. Hybridization involved is sp3d2. sp3d2. Okay? sp3d2. Perfect. Talk about I3 negative. Talk about I3 negative. I3 negative can be first of all written like this. I2 negative. You can write it like this as well. I2 negative. That means I3 negative. Now first of all, this iodine, how many valence electrons it has? 7. But there is a negative charge. So make it 7 plus 1. That's 8. How many surrounding atoms? 2. Therefore 2 sigma bonds. How many lone pairs? Out of 8, 2 valence electrons are used. So 6 valence electrons are as such in the form of 3 lone pairs. 3 plus 2 is 5. So steric number is 5. And when the steric number is 5, hybridization involved is sp3d. sp3d. Am I clear? Am I clear? Am I clear? ClF3. ClF3. Cl. How many valence electrons? 7. How many sigma bonds? 3. So how many lone pairs? Out of 7 electrons, 3 are used. So 4 are still left. 4 means 2 lone pairs. Steric number 3 plus 2 is 5. If steric number is 5, hybridization involved is sp3d. Done? Perfect. If I ask you which d orbital is used here, it is dz square. Right, people? SF4. Again, you can check it out. 4 sigma bonds, 1 lone pair, sp3d. Correct? Correct, people? For example, I'm giving you NO2 negative. NO2 negative. For example, I'm giving you XeOF4. XeOF4. Here, there are certain changes. See how you are going to remember. Understand. See, guys. First of all, if we talk about this nitrogen, how many valence electrons it has? 5. But there is a negative charge. So 5 plus 1 make it 6. How many surrounding atoms? 2. That means 2 sigma bonds. Right? What do we normally use to do? 6 valence electrons, 2 sigma bonds. So there should have been 4. 4 valence electrons should have been left. Right? But oxygen is a divalent. Oxygen is divalent. Imagine as if one oxygen atom has formed 2 bonds. Just imagine it like this. One oxygen atom, for example, has formed 2 bonds. So total there are 4 bonds then formed. So out of 6 valence electrons, 4 have been utilized. So 2 are only left. 2 valence electrons are only left. 2 valence electrons means 1 lone pair. Sigma bonds are 2. That means lone pair is 1. Am I clear with what I said? Are you guys clear with what I said? Are you clear with what I said? Oxygen here is divalent. Imagine as if oxygen is forming, one oxygen atom is forming 2 bonds. Right? So if one is forming 2, in total 4 bonds. 6 valence electrons in total. 4 valence electrons utilized to form 4 bonds. 2 valence electrons are left here. That means 1 lone pair is left. 1 lone pair. So steric number 2 plus 1, 3. Steric number 3 means sp2. Got it? Got it, people? Look at the next one. XeOF4. Xenon. How many valence electrons? 8. How many surrounding atoms? 4 plus 1, 5. 5 surrounding atoms. 5 surrounding atoms. Now lone pairs. See, out of 8, 4 have been utilized with 4 fluorine atoms and 2 with oxygen. So 4 plus 2, 6. 8 were there in total. 2 are left in the form of 1 lone pair. Steric number is 5 plus 1, 6. Hybridization involved is sp3, d2. If I ask you which d orbitals are involved, it is dz square. and dx square minus y square that's involved. So I hope all these concepts which I have discussed with you till now, I hope they are clear. Are they clear? Let me know once in the chats. And how many concepts we have discussed till now? I think we have discussed 9 concepts. Is that? Yes, this was your concept number 9. Right? That is calculation of hybridization. So all the 9 concepts are clear. And I think this much is enough for today. You should also not get bored. You should also not get bored. And this PDF I'll be sharing in the Telegram. Can you tell me the answer of this question? Quick. Quick. What is going to be the answer of this question? S and P, how they are going to overlap, right? SP direct overlap, head-on overlap. Bond angle is going to be 180. Bond angle is going to be 180. Done? SP to SP to SP, SP. See, this carbon is forming 3 sigma bonds. 3 sigma bonds, right? So SP2. This carbon is forming 3 sigma bonds. SP2. This carbon is forming 2 sigma bonds. SP. This carbon is forming 2 sigma bonds. So SP. Steric number 3, steric number 3, steric number 2, steric number 2. Okay? Remember, if for example you have got a structure like this, you just have to count the sigma bonds here. How many sigma it's forming? 1, 2, 3. 3 sigma bonds means write directly SP2. 3 sigma bonds here means SP2. For example, you have got NH3. You have got NH3. Nitrogen has got 1 lone pair as well. 1 sigma, 2 sigma, 3 sigma and 1 lone pair. 3 plus 1, 4. SP3. Right? Perfect. In D to SP3, SP3 D2, which D orbitals are used? Quick, everyone. In case of your D to SP3, which D orbitals are used? Few minutes back only I said. Quick. Few minutes back only I said. It's option A. Okay, it's option A. Which orbitals are involved in the hybridization in case of ASF5 molecule? This is arsenic, group 15. How many valence electrons? In group 15, there are 5 valence electrons. Sigma bonds, 5. Lone pairs, 0. Steric number, 5 plus 0, 5. Hybridization involved is sp3d. If it is sp3d, so there is 1 s orbital. There will be 3 p orbitals, which is px, py, and pz. And which d orbitals will be there? It is going to be dz square. Right? S, px, py, pz, dz square. Done? Done, people? Perfect? Right? So, I hope all the stuff is clear. So, in the today's session, we have discussed some 9 concepts. And in the comment section, I would want to know whether all the concepts are clear. Okay? Tomorrow is Yavar sir session. Day after tomorrow is Ambika ma'am session. After that, there is HSP sir session. After that, again, I'll come up with further 10 more concepts with all of you. I hope you liked this. And these 9 concepts, guys, trust me, 9 multiplied by 4, it means 36 marks. And these are guaranteed 36 marks, I'm telling you. These are guaranteed 36 marks, I'm telling you. Okay? And one thing, I would want in the comments that, what is that? What is that I would want in the comments? Whatever thing you would want to write in the comments, do write that. Okay? I'll check it out. Or just write day one, done and dusted. Day 1, done and dusted. You should write in the comment section of this particular video. So with this, I'm taking a leave and I'll see you after 3 days with further 10 more concepts. Till then, you can enjoy with your bio and physics. And I hope all the concepts were crystal clear. And from these 9 concepts, these are the questions which will be asked in your NEET examination, not more than this. Perfect, people. So take care. I'll see you in the next session.